Hello everyone. Today we'll be discussing about cut-set matrix. In last few classes we discussed about basic concept of graph theory, basic terminologies associated. Then we discussed about incidence matrix, tie-set matrix. So all these matrices are used to formulate network equations. If we have a very complex circuit for which network formulation or for network equation is to be obtained, it is a bit difficult to follow the conventional network topological rules. In that case, we may offer these matrices to determine the network equations, which actually will represent the system. Now, today we'll be discussing about another matrix, which is known as cut-set matrix. So these are the topics to be covered today. First, we'll be discussing about introductory part of cut-set matrix. Next, we'll move to formation of cut-set matrix, and then we'll solve some numericals on it. So what is a cut-set matrix? Or before discussing cut-set matrix, let us first discuss what is cut-set. It is a set of branches when cut or removed from a graph separates the graph into two groups of nodes or splits the graph into two isolated graphs. What does that mean? Let us take an example. Let us consider this graph having 5 branches: branch 1, branch 2, branch 3, branch 4, and branch 5. Now let us mark all the nodes A, okay. Now if we cut a set of branches, as mentioned here, it is a set of branches that when cut or removed split the graph into two parts or different groups of nodes. So let us cut this set of branches. If this set of branches cut from the graph, then there will be one part which will not be connected to this part. So these two parts are isolated. How these parts are becoming isolated? When we cut 1 and 3 branch, then only this part will be remaining. So this is this set of branches. This set of branches are minimum set of branches which are to be cut or removed to obtain two isolated graphs. Here see, node A becomes entirely isolated from the graph, from the main graph. So this is known as cut set, a set of branches which are cut to isolate two different to get two isolated graphs from the main graph. Now cut set defines minimum set of branches. If these branches are removed, the graph results in an unconnected graph. Now see, these are resulting in unconnected graph. So these two branches are together termed as cut set, which is comprising a minimum set of branches. Now, while forming a cut set, it should consist of one twig and one or more links. How to describe this point? Suppose you have one such graph. In this graph, there is node A, node B, node C, and node D. And the links branches are 1. I'm not showing directed graph here for simplicity, but cut-set matrix has to be obtained for directed graphs only. These are 5 branches. Now, as per the property of graph, first what you need to do, we need to get tree corresponding to the graph. So tree corresponding to the graph will be in a tree, all the nodes has to be present. So let us first mark all the nodes A, B, C, and D. Now, for 4 branches, there should be 3 twigs, as number of twigs for n number of nodes graph should be n minus 1. So number of tree branches or twigs should be 3. So let us consider any 3 branches. One branch. You can consider any 3 branches which will make unconnected, or sorry, not closed loop, which will make no closed loop. So here we have considered this 3 branches. Branch 1, branch 2, and branch 3 are considered of the branches of the tree, of a corresponding tree. So remaining will be the links. Links are shown by dotted line. Okay, so one link will be numbered as 4, another will be numbered as 5. Now see what happens. A cut set, it contains only one twig and other links. So in a cut set, there should be only one twig, not more than one twig. So see here, if we cut these 2 branches, A node will be isolated from the entire graph. But we cannot cut these 2 branches together to form a cut set, because a cut set should consist of only one twig, not more than one twig. As 1 and 3 both are twigs, so this cannot be a cut set. Okay, clear? This could be a cut set because here it is involving only one twig, that is 2. This could be a cut set. Okay. And what else we can consider? We can consider this one as a cut set. Okay. So here 3, 4, 5 could be considered as a cut set in which only 3 is cut set, only 3 is the twig. We can consider one cut set with 2 and 5, only 2 twig. We can consider 3, 4, 5 is already considered. So let us consider this part only. If you cut 3 and 4, then also you'll get one cut set. Okay. Now, for a tree, for a particular tree, card set is to be obtained. Now, to obtain a card set, how many card sets should be there for a particular tree? That depends on number of twigs, because each card set should contain only one twig. So if there are 5 twigs, then there should be 5 card set involving one twig each. So number of card sets of a graph with respect to a tree should be number of twig. So for a particular tree, number of card set will be n minus 1. Okay. Again, I'm telling you, this could be one card set. This could be one card set. You may consider this as another card set. Okay. This is also involving 1, 4, and 5, only one twig. So there will be only 3 card sets, as number of twig in this case is 3. 1, 2, 3 are 3 twigs. Okay. So first card set is formed with twig 3. Second card set is formed with twig 1. Third card set is formed with twig 2. So hopefully these points are clear now. Now, formation of a card set. How to form a card set matrix. See, first task of forming card set matrix is to choose a tree arbitrarily. You can choose any tree. Someone can choose this tree, which is shown by bold, and the dotted are showing the links. You can choose some other set of branches to form a twig, to form a tree. So it's up to you which tree you will choose. Form fundamental card sets with one twig and other links, as we discussed. Fundamental card sets should be formed with only one twig and other links. This is very important point. Assume direction of card sets, the direction of twigs. So direction of twigs will be mentioned in a directed graph. The card set corresponding to that particular twig has to be in the same direction of the twig. Okay. Now, once direction of card set is mentioned, direction of each branch will be given for a directed graph. So if a branch has same orientation of the card set, then the matrix element will be 1. If branch has opposite orientation with the card set, matrix element will be -1. If branch is not part of card set, then matrix element will be 0. Now, what can we say here? Branch, if a branch and card set is having same direction, it will be straight away placed with +1. Now what happens if someone considers -1 in this case, then in opposite case he has to consider +1. So it's up to you which one you will consider. Okay. Now, based on the concept which we acquired in today's class, let us try to obtain card set matrix for this particular graph. So first task is to form a tree. So a tree is formed. There are 4 number of nodes, and there should be 3 tree branches or twigs. So here we have considered E, A, and C as 3 twigs. Now card sets will be formed. This C1 is formed. This is C1. Okay. C1 is formed with this one, which involves A, B, D. A is twig, B and D are links. So this is one valid card set. So first C1 is formed with A, B, and D. Next, C2 is formed with another twig. Another twig is C. So C2 is formed with C. Okay. C, D and F. Okay. And third cut set C3 is formed with this one, E, B and D, where E is the twig. So in each case, for each cut set, there is only one twig. So number of twigs should be equals to number of cut sets. So as we have got 3 cut sets, so we'll have to stop here. So look at this. I think it's clear to everyone now. Now let us form the matrix. C1. Acha. Before forming the matrix, see direction of C1. This is C1. This is direction of A. So C1 is directed in this direction. Likewise. Okay. So A has same direction as C1. So A is +1 for C1. This C1 is involved with B as well. So B is also in same direction with C1. B is 1. C1 is connected with D as well. So see, through C1, this is the direction. Okay. So through C1, this is direction, but D is in this direction, which are in opposite direction. So D has to be -1. Okay. As C1 involves this 3, so remaining 3 will be 0. Now let us move to C2. For C2, C2 and C. See, C2 is in this direction. So C is in the same direction. So C will be +1. D is in opposite direction. This is direction of D. And this is direction of C2. And 3 is also in opposite direction. F is in opposite direction to C2. Remaining 3 will be 0. What about C3? This is C3. This is direction of E. So C3 has to be in this direction, this direction, this direction, and this direction. So E and C3 are in same direction. So E will be 1. B and C3 are in same direction. B will be +1. D again in opposite direction. This is direction of D and this is direction of C3 through this. So D will be again -1. Remaining will be 0. This is how we can form cut set matrix. Clear? Okay. Let us now consider this one. Here we have 5 nodes and 6 branches. Let us try to obtain cut set matrix for this. As we have 5 nodes, there should be 4 twig. There is 4 tree branches. So let us consider a tree arbitrarily. So a tree is considered with branch 1, branch 2, branch 3, and branch 6. So branch 4 and branch 5 are considered as links. So this one is first cut set. This one is first cut set, which is involving link 1, link 4 and twig 1. So twig 1, link 4 is first cut set. Similarly, second cut set could be obtained with 3 and 4. where 3 is twig. Third cut set can be obtained with 5 and 6, where 6 is twig. And fourth cut set could be obtained with 4, 2, 5, where 2 is twig. So there are twigs as 1, 2, 3, and 6. One twig is, first cut set is formed with twig 1, second cut set is formed with twig 3, third cut set is formed with twig 6, and fourth cut set is formed with twig 4. So all twigs are considered separately to form each cut set. So you have got 4 cut sets. Now, the direction of C1, this is direction of twig 1. So direction of C1 will also be in the direction of twig 1. So for C1, twig 1 is in same direction with C1, but twig 4, this is direction of C1. So link 4 is having opposite direction with C1. So while matrix representation, C1 will be associated with branches like this. Branch 1 will have +1 and 4 will have -1 for C1. So for C1, branch 1 is +1, branch 4 is -1, and remaining will be 0. Similarly for C2, it will be oriented in the same direction as 3. So 3 is +1. This is orientation of 3 for C2. So 4 and C2 are in opposite direction, which implies 3 will be +1, 4 will be -1. For C3, 6 will be +1, 5 will be -1. Remaining are 0. For C4, 2 will be +1, 4 will be -1, 5 will be +1. So 2 and 5 +1, 4 is -1. 2 and 5 +1, 4 -1. So this is how you can solve for cut set matrix for any particular graph. So first you need to obtain a tree. From that tree, you need to consider the cut sets. Number of cut sets should be equals to number of twigs. Each cut set should contain only one twig. Direction of cut set should be in the direction of twig. If these points are remembered, then you can easily find the cut set matrix for a particular graph. So what do we discuss today? We discussed about the introductory part of cut set matrix, how to form cut set matrix. Later we solve few numericals on cut set matrix. So this is up to this. We'll be discussing few numerical on graph theory, that is incidence, formation of incidence matrix, trisect matrix, and cut set matrix in next class. So thank you all. Meet you in next class.